Okay, let's set a scene. You're watching the monitors, maybe on a critical pipeline, maybe a processing facility.
High stakes?
Exactly. Suddenly, system pressure spikes. You see those telltale signs? A valve starting to fail.
And it's not a slow drip we're talking about.
No, definitely not. It's a high-pressure leak, shutdown looming, environmental risks, safety alarms going off.
It's happening now. No
Yeah.
time.
And in that moment, what really matters, what makes the difference between, control and catastrophe, it's the emergency sealant you have ready.
That's the critical point.
And that terrifying crossroads is why we're doing this deep dive today. We're looking at one very specific product, Val-Tex 700+FTFE Valve Lube Sealant.
A real industry workhorse.
Our mission, using the material you sent over, is to figure out why this specific stuff is seen as, well, the gold standard for emergency response, especially in really harsh environments.
What makes it so bulletproof?
Yeah, what are the technical specs that let it dominate? Because there seems to be this split, right? Some operators use good enough sealants,
Hoping for the best.
while the major players, they demand these high-performance proven solutions because failure, it's just not on the table for them.
Cool. The cost of failure.
Yeah.
That's where you start. The sources are really clear on this. Valve leakage, especially high pressure or corrosive stuff, it's instant trouble.
How so?
It's defined in like 3 immediate ways. Lost revenue, almost guaranteed environmental exposure, and basically a safety report just waiting to happen.
So standard sealants.
Most standard lube sealants, they just can't handle it. They pretty much throw in the towel when they face that unforgiving gauntlet of aggressive media.
Like, what kind of media are we talking about?
Think high-pressure hydrocarbons, maybe combined with big temperature swings, or, and this is crucial, sour crude and sour gas.
Okay, wait. For anyone listening who isn't, a hands-on engineer, sour gas or crude, what makes that uniquely threatening? Why is that such a big deal?
Right, good question. So sour just means the oil or gas has significant amounts of hydrogen sulfide, H2S.
And H2S is?
It's nasty stuff, highly toxic, super corrosive. Under pressure, it just eats away at standard polymers, attacks metal alloys really fast.
So a normal sealant just dissolves?
Pretty much. A lesser sealant degrades almost on contact. Turns a small leak into a massive problem, like instantly, especially with H2S.
Wow. Okay, that really clarifies the mindset then. The big operators, oil and gas majors, large utilities, they're not just crossing their fingers.
No, they budget for this. It's an investment.
They're planning to win against that kind of failure. Keep the line running.
Exactly.
So let's unpack the engineering behind this 700+ FTFE. The sources paint it as a real material science win. You mentioned composition is key. What's actually in it?
Okay, first big thing. It's made from synthetic compounds, and importantly, they're biodegradable.
Ah, interesting. Performance and environmental standards.
Right, that's a big deal nowadays. But the real sealing power, the muscle, that comes from the second part. It's loaded with Teflon.
Teflon, like in pans.
Sort of, but think industrial grade. The product name, 700+ FTFE. That stands for fluorocarbon Teflon enhanced.
Got it.
That Teflon gives it structural integrity, makes it chemically inert, resistant to attack, and most importantly, provides that instant sealing action even under severe pressure.
Okay, but hold on. Adding all that Teflon, that must make it way more expensive than just a standard grease, right?
Oh, absolutely. The upfront cost is higher.
So how do the smart teams sell that to, the finance department before there's an emergency?
That's the strategic calculation. You don't compare the cost of the sealant stick to stick. You compare the cost of the sealant to the cost of an unplanned shutdown.
Which can be huge.
Millions per day, potentially. Plus cleanup costs, fines. So a few sticks of this stuff, it's basically insurance. It doesn't just lubricate, it seals active leaks under pressure.
That consumability makes the cost seem pretty small then.
Especially weighed against an H2S leak or a big environmental incident. Yeah, negligible.
This is where it gets really interesting for me, the actual specs. What makes it bulletproof? You mentioned temperature extremes. What kind of range are we talking about?
It's pretty incredible. It works reliably from like Arctic cold at -20 degrees Fahrenheit.
-20 F.
All the way up to furnace-like heat, plus 450 degrees Fahrenheit.
Wow, 450 F. That's a huge range.
Massive.
Yeah.
And that means versatility.
Yeah.
You don't need 5 different sealants for different climate zones or different parts of the process.
One product covers a lot of bases.
Exactly.
Yeah.
And that versatility carries over to chemical resistance too. Because of that Teflon base, it handles, well, pretty much everything. Basic hydrocarbons, sure, but also the tough stuff.
Like the sour gas.
Sour gas, sour crude, big CO2 surges, even environments with lots of oxygen. It's genuinely multi-purpose.
So operators can simplify their inventory.
Definitely. You could basically use this emergency lube sealant on almost any valve type in a plant, on a rig, whatever. Less complexity, less worry.
Yeah, that complexity reduction. That's a lifesaver in a crisis. Last thing you need is the crew arguing over which tube is rated for what, right?
Absolutely. Time is critical.
Okay, let's shift from the data sheet to the drama on the job site. The sources mention scenario, let's call it scenario A, high pressure gas transmission.
Right.
Mainline valve starts venting gas. 400 psi, relentless. A lesser sealant would just get blown right out.
Yeah, imagine being the crew chief there. The stress levels off the charts. You see that gauge spiking, you know your standard stuff won't hold.
That's why they keep 700+ FTFE nearby.
That's exactly why. The formulation, that Teflon synthetic blend, it's designed so the pressure actually helps it. It pushes the sealant into the leak path.
Ah, uses the pressure against itself.
Exactly. It gets forced in, it expands slightly, and bam, it sets up a strong, resilient seal instantly.
And that keeps the operation online.
Buys you time, critical time, hours, maybe days to plan a proper, safe, scheduled repair instead of a chaotic emergency shutdown.
Okay, let's connect that to another scenario from the sources. Scenario B, onshore, offshore oil patch. Much messier environment.
Right. Corrosive salt water, brutal heat. Those complex hydrocarbon cocktails. It's tough out there.
So logistically, how does this work? This stuff needs to be ready to go.
Right. It comes in different forms, sticks, paste, even bulk drums. And it loads straight into portable air-operated grease guns.
Like the standard ones crews already use.
Yeah, like the Val-Tex 700 gun, that kind of thing.
Yeah.
So, instant deployment. You get the gun, load it, inject it, seal the leak, protects the crew, keeps production on schedule, avoids that panic.
And this brings us back to something you mentioned earlier, the biodegradable part. That's not just like a green check mark, is it? It sounds like a serious compliance advantage.
It absolutely is. Compliance is everything these days. Think about the procurement managers, the EHS teams.
EHS.
Environmental health and safety. They're under huge pressure to tick every single regulatory box.
So the fact that 700+ FTFE is tough enough for the job and biodegradable
Means regulators see you're being proactive. It helps avoid not just the massive cost of an environmental incident, but also the reputational hit that always comes with it.
It turns material choice into actual due diligence.
Precisely.
Okay, so that pivots us nicely from the material itself to the supply strategy. If this product is the answer, what separates the, let's say, smart procurement teams who keep it stocked?
From the ones who, as the sources say, learn the hard way. Penny pinchers, maybe.
Yeah, maybe. What's the difference?
It really comes down to scale and reliability in your supply chain. Smart operators aren't buying this stuff at the local hardware store.
No.
No way. They partner with specialized, high-volume industrial suppliers. People who understand what it means to run hundreds of valves, not just fix a leaky faucet.
So bulk pricing, logistics designed for industry.
Tailored for operators, not hobbyists. Yeah.
And crucially, you mentioned speed and documentation. That defines a real strategic partnership, doesn't it? Especially for emergency stuff.
Couldn't be more important. You need guaranteed direct-to-site delivery. When you need it, where you need it. Ready for your safety procedures, not just whenever a generic truck shows up.
But the documentation piece, that's the real strategic value add.
I'd argue yes. Every single shipment from a quality industrial partner has to come with rock-solid paperwork. The full SDS.
Safety data sheets.
Right, and the comprehensive technical data sheets.
Why is that documentation, the SDS and data sheets, so critical? Isn't performance enough? If it works, it works.
Not in today's world. Compliance and inspection readiness. They are absolutely non-negotiable. Legally, ethically, safety-wise.
What happens if you don't have it?
Imagine a regulator walks onto your site. They see you've injected something into a critical valve. If you can't produce the current, correct, verifiable SDS for that exact material, you're in serious trouble. It's a reliable wholesale partnership. They guarantee the documentation is there every time. The supply chain itself becomes part of your risk management strategy. Proactive, not reactive.
And that kind of partnership often means access to more than just this one sealant, right? Like the sources mentioned Val-Tex 85 or 750. Why is that broader portfolio important if 700+ FTFE is the main emergency workhorse?
Good point. Because not every valve does the exact same job under the exact same conditions. 700 plus FTFE is amazing for high-pressure emergencies, incredibly versatile.
Yeah.
But maybe for certain storage valves or plug valves operating differently, Val-Tex 85 is the optimal choice. Or if you're dealing with really extreme cold, way below that negative 20F, maybe Val-Tex 750 is specifically formulated for that.
So it's about having the precisely right tool for each job.
Exactly. Not just a good enough tool, the right tool. And getting them all efficiently, reliably documented, ideally from one trusted partner, that simplifies everything.
Okay, so boiling this all down for you listening, it sounds like the goal for top industrial operations is pretty straightforward. Buy once, get it right, never worry again.
That sums it up nicely.
This procurement strategy, it's not just about saving a few bucks here and there. It's about buying peace of mind, delivered at wholesale scale.
Yeah, the best operators, they choose products like this and they build these focused supply chains because they've fully baked urgency, precision, and reliability into their core strategy. That's how they operate.
They stock this stuff proactively.
Right. Not because they want to leak, but because they know, statistically, failures happen. They've modeled it. So when that next emergency inevitably hits, they already paid for and have the answer sitting right there on the shelf.
That really leads to a final thought, something for you to consider. We've talked a lot about the necessity of full documentation, those SDS, the data sheets for compliance, for managing risk.
Absolutely critical.
So here's the question to mull over. How does relying on a proven, well-documented wholesale partnership fundamentally change how your organization manages risk? Compare that to, say, relying on maybe cheaper but unvetted or undocumented supply chains, where you might save $1 today.
But risk millions, or worse, tomorrow. Think about that deep link between your procurement strategy and your long-term organizational risk profile.